The head table, judging panel, and my dear presenters, a very good morning to you all. Today, I'm delighted to be a part of this scientific conference in Malaysia. I'm Mohammed Jeffrey Ifran from School of Science, BMS, Sri Lanka, going to present about docking study using vina for phytochemicals from Mangifera zeylanica to treat dengue. It's my pleasure to present here on behalf of my co-authors, Ominda Pereira and Heshani Mudalige. First of all, if we move to the background of the study, dengue fever is a mosquito-borne viral disease which is a serious illness up to now. In Malaysia, dengue fever is a major cause of morbidity and mortality as attested by Chian et al. In 2014. Likewise, the figure 1 shows the seriousness of this infection in Sri Lanka from 2010 to 2019 as it peaked in 2017. The figure 2 depicts the common symptoms of dengue such as eye pain, fever, muscle pain, headache, and so on. Having said that, the significance of this study is mainly covering the unavailability of curable drugs for dengue and the clinical trials conducted for past 50 years also not that productive and efficient. As NS2B NS3 protease in dengue virus has become a key target for viral destruction, we have chosen that as the target receptor for our study. Moreover, no protease inhibitors have been discovered so far. Furthermore, utilization of open source software reduces the cost of the research. Next, we are on objectives. The general objective of this study is to identify ligands as drug candidates against NS2 NS3 protease receptor for treatment of dengue. The specific objectives of the study includes to familiarize with software such as Autodoc Vina, OpenBabel GUI, and Pavia Discovery Studio, to identify best ligand binding site of NS2B, NS3 for dengue using Vina, and to identify potent phytochemicals and their binding site against NS2B, NS3 protease receptor. As we are moving to the materials, computational requirements such as hardware, software, and website and tools are on the slide number 5. For this research, PC with processor 11 Gen Intel Core i7 and RAM with 8 GB was used. Now we are on methodology. Initially, the 3D structure of the receptor, which has the PDB ID of 2FOM, was downloaded from RCSB PDB website and prepared by deletion of water and heteroatoms along with the repair of missing atoms. Then, addition of polar hydrogen and Coleman charges was accompanied. Then the charges were spread. The ligand structure, which were listed out from the study by Selvakumar et al. 2022, were retrieved from PubChem website and converted into PDB-QD format from SDF using OpenBabel GUI software. The execution of docking was accompanied by the creation of configuration text file and batch file. For the analysis of the results, Vina output files were saved as PDB file and opened in Bavia Discovery Studio to visualize interaction and best docking process. The canonical smiles of the phytochemicals were copied from NCBI PubChem and pasted in Swiss ADME web tool to analyze the ADME properties of the phytochemicals. Having said that, we are moving to the results. The dock results obtained from Vina are listed in the table 1 while the best docking pose of phytochemical is depicted figure 3 and as well figure 4. Lupiol showed the lowest binding energy minus 8.9 kilocalorie per mole, while benzoic acid showed the highest binding energy minus 5.1 kilocalorie per mole. Lower the binding energy, more stable the ligand. The interaction with respect to hydrogen bond and hydrophobic interaction of the phytochemicals is shown in the table 2. The stability of the ligand increases with number of hydrogen bonds. Though Lipiol showed the lowest binding energy, It does not have hydrogen bond interaction with the receptor, while isomangiferin showed 4 hydrogen bonds. If we move to the next slide, Figure 5 exhibits the interaction image obtained in Bavia Discovery Studio. Gallic acid, isomangiferin, and quercetin revealed unfavorable bump with receptor, which is indicated in red circle in the Figure 5. Table 3 depicts the ADME analysis of phytochemicals, including Lipinski's rule and GI absorption. Mangiferin and isomangiferin do not obey Lipinski rule and have low GI absorption rate. GI absorption is considerably important for oral drugs development. If we move to the discussion, docking studies confer many advantages in early stage drug development compared to in vivo and in vitro studies, such as speed and the ability to predict a molecule's properties before synthesis. This is the very first docking study to target NS2B NS3 pathway from phytochemicals from Mangifera zeylanica. NSA interference compounds, referred as paints, are chemical compounds that often will give false positive results in high-throughput screening. Paints tend to react non-specifically with numerous biological targets rather than specifically affecting one desired target. Unfavorable bumps were detected in some of the phytochemicals. It can be due to rigid docking, unexpected mode of action, or different binding site for that particular phytochemical. While, while preparing the receptor, water molecules and heteroatoms were deleted in aims not to disturb the binding site. Uncommon charges, which is calculated from electrostatic potential, were added to 2FOM receptor to calculate the net atomic charge of the receptor. Missing atoms were repaired to optimize the physiological condition for the receptor outside the body and inside the computational program. To identify the hydrogen bond interaction, dipole hydrogens were added. Vina utilizes a gradient optimization algorithm. To conclude, since epicatechin obeys Lipinski rule and GI absorption is also high without blood-brain barrier permeation with one plane with significant binding affinity of -8.5 kilocalorie per mole, it can be chosen as a potential drug candidate for further experiments to treat dengue. Based on the results, Leucine 149 was identified as a common amino acid residue concerning hydrogen bond, and leucine 76 was identified with respect to hydrophobic interaction. We move to the suggestions and future work. Network pharmacology and protein-protein interaction can be persuaded in future. Gene ontology and KEGG enrichment pathway analysis also can be carried out in further. Quantitative structure-activity relationship study is helpful in future to carry out this research to another step. Prediction of activity spectra for substances, which is known as path prediction for phytochemicals, also can be performed. Importantly, in vivo and in vitro experiments based on results can be done in future. The slides number 14 and 15 shows the reference of this study. These are my references. Thank you for your attention and cooperation. Thank you for listening to me. Thank you again.